In this video, I'm going to give you the opportunity to try one of these elimination problems. I want you to solve this system of differential equations by elimination. My suggestion is for you to solve for y up here. It's a little bit easier. That's also the way that I'm going to do it. So if you want to have work that matches what I'm going to put up in a moment, then you should do it that way. And then also after you do what I taught you to do in the previous video, I want you to, I'm going to show you how to solve for the initial conditions, or solve for the C's given the initial conditions. So at this point, I want you to hit pause, and I want you to try to do elimination with this right here. I am going to do it at the same time, and then I'll walk through the solution so we can see if we agree. So hit pause. Here comes the solution set. Okay, here is the full solution set right here, or the full solution method. I'm going to walk through things. You probably got to here. I don't think I said that. I don't think I suggested that you get to this form of the answer, but I'll walk through it. So first thing I do is I solve for y. That gives me this blue equation right here. Take the derivative. It gives me the green equation. Then I'm going to sub those into here. So I just rewrote this equation right here, y prime minus 2x plus y, or equals minus 2x plus y. And then in the green was this one right here, so that went there. This is the blue, which is that. So I get this. Simplify, get that. Do a characteristic equation. This is probably where the most mistakes in this are made, because everyone always has trouble when we have a 5 and a 6 here. Do I choose 6 and 1, 5 and 1, whatever? It's -2 and -3. Gives me R values of 2 and 3. Hopefully you did get that. Ba-bam. That's my X equation. That's what goes in here for my final answer. But I also need to find the Y value, or the Y equation that's going to solve this thing. So I need to take the derivative, and then I slide both these up, and I plug them into this blue equation right here, because that gives me y in terms of x prime and x. So I do this, I do some multiplication, simplify a little bit, and I get these guys. And that comes to be my y form of the equation. And then I do want you to get used to writing them in this form. So we can factor those C1s and that e to the 2t out. That is the C1 and the e to the 2t. And then I'm left with a 1 and a -2 there. And same thing here. We got a 1 and a -1. Bam. And the C2 is out front, and the e to the 3t is on the right side. So hopefully you got that. Now I'm going to show you how to deal with these initial conditions. So I will zoom in a little bit. We could use this form right here, but for now I'm just going to use this form, and I think you'll see exactly how we do this. So notice x of 0 is 7, and y of 0 is -12. So what I can do is, zoom out just a hair, write 7 equals, and then plug in t equals 0 for this equation right here. I get C1 e to the 2 times 0 is 0, plus C2 times e to the 3 times 0 is 0. And then down here, similarly, I get -12 is equal to -2C1 e to the, we get a 0 again, and then minus C2 e to the 0. Now, notice e to the 0, that's just 1 everywhere. So we really quickly get a system. It's like a linear system. It's not a system of differential equations. We get a system, 7 equals C1 plus C2. And -12 equals minus 2C1 minus C2. And this we can solve using stuff from algebra. And you should see that now that you know that this is the strategy, you probably don't have to write these two lines here. You can just plug in that 0 automatically and say, all right, I get this line right here. So in order to solve this, I'm going to use elimination because the C1 and the C2 very conveniently cancel out. That's not going to happen all the time, but here I'm going to take advantage of it. So when I add those, there's no C2. So when I add this and this, I get negative C1. And when I add these two, I get negative 5. So that tells me that C1 is equal to 5. And then from there, I can plug that into this equation. If this is 5, subtract it, I have a 2 on the left side. So that tells me that C2 is equal to 2. So from there, I can zoom to there. I have two forms of my answer here. I'm going to actually write this one first, and we'll go back to purple. My first form is going to be plug in a 5 here. So I get x, y equals, right? If I put a 5 there, I can now actually distribute that into there and have it be a little bit more clean. So that gives me a 5 in the top and a negative 10 in the bottom times e to the 2t. And then plus the C2 is 2. So that gives me plus, no, whoops, my bad. Open bracket, or open parenthesis. If I put a 2 here, it's going to multiply and give me a positive 2 and a negative 2. So 2 negative 2 e to the 3t. And the other way to write this would be x equals, and you could plug in the 5 and the 2 here, here, and here. But I've already done that work here, so I'm just going to do my multiplication 5 e to the boom plus 2 e to the boom. So I get 5 e to the 2t plus 2 e to the 3t. And my y is going to be same across, minus 10 e to the 2t minus 2 e to the 3t. And either one of those would be a good answer depending on depending on what I want to do with this thing. Usually, we like this solution better because we can do more stuff with it. And again, as I said earlier, we are going to talk about alternative ways to solve these, and we're going to talk about applications of these things, how this plays a role in reality. And lastly, we're going to talk about visualizing, creating a visual representation of what actually this right here means. We can create a graph of this thing that is super useful and informative. So that's all for this video. See you next time.